We thank Avi Bashan for being with us today. Avi just recently presented his research at Black Hat 2015. We are very happy to have him with us today. He has more than 10 years of experience in the mobile networking and security industry, apart from working with organizations like Lacoon, Checkpoint, etc. Avi was a leading security consultant at ComSec, working with Fortune 500 firms on their vulnerability management processes. He spent 4.5 years in the Israeli Defense Force. Avi holds a BMed Science from the Hebrew University of Israel in Medical Studies. I hope I pronounced that right, Avi. He has spoken at many
Yeah,
top-tier conferences. Thank you, like Black Hat USA. We'll start the webcast series right away, and I'll pass over the control to Avi. Avi, over to you.
yeah, okay. So hello all, and thank you for joining us. So what we're going to talk today. So today we're going to talk about certifi-gate. It's a major vulnerability that our research team have found a few months ago in Android. And it affects hundreds of millions of Android devices. So what we're going to talk about. So at first we're going to talk a little bit about mobile threats in Android and motivation for doing our research. Then we're going to talk a little bit about mobile remote support tools. Then we'll continue to talk about how we can use attack mobile remote support tools in order to take control of Android devices. And in the end, I will conclude the research and talk about mitigation steps that you can take in order to protect your organization. And we'll do a little bit of Q&A. So, Risha already introduced me. So I'm Avi Bashan, and I'm was a security researcher and a CISO for Lacoon. We were recently, a few months ago, acquired by Checkpoint, and now I'm leading the security research in Checkpoint. I want to thank other contributors to this research that helped a lot in it is Pavel, Daniel, Andre, and Denis. So let's talk a little bit about mobile remote access trojans, or mRATs. So what's an mRAT? It's a tool that can access your device, and it provides unauthorized access to the data on the device and to the sensors of the mobile device. So it can access sensitive data such as calendar, contacts, email, and use the sensors in order to get more information, such as record calls or open the GPS and get the device location. So there's a lot of popular mRATs tools today in the wild. Maybe you heard of some of them. Mobile Stealth and mSpy are commercial tools that can be bought. Hacking Team is also a company that creates more mRATs. You probably heard of them in the recent hack, and we saw that they sell mRATs to governments and other corporations. And another tool that maybe you heard of is Dandroid. It's a framework that allows you to repackage existing app and insert malicious code into it, and making the app malicious and allow an attacker to use any app in order to take control of a device. So these are the mRATs. And checkpoint, what we do is part of our detection mechanism and strategy is to develop and analyze a lot of different APKs and try to understand what they do in order to detect mRATs. So while categorizing the various capabilities that mRATs have, we saw that a lot of them have similar traits, similar capabilities, such as a lot of mRATs install apps. A lot of mRATs try to get access to the screen, or maybe do user input control, meaning allowing an attacker to control the device as the user from remotely. And in order to get all of those capabilities, we saw that most of the mRATs use exploits because these are something that regular apps cannot do, only apps that have more advanced permissions. So while analyzing the various apps, we saw another family of apps that has all of those interesting capabilities and that mRATs has, but doesn't use exploits in order to get them. This intrigued us. It's very interesting to see this as such a thing. So we understood that this family is an mRST family. What's an mRST? It's a mobile remote support tool. So what's a mobile remote support tool? It's a tool that allows a technician to supply support to the device, such as you probably know these kind of tools from the PC world as well, and it's used by IT departments or mobile carriers and even device manufacturers in order to provide to people help with their tools. The main players in this field is a lot of players that also are in the PC area, such as TeamViewer, LogMeIn, and Citrix. And also a very big player in the mobile field is AllSupport. It's a Korean company. So, in order to understand more how the mobile remote support tools work, we try to understand its architecture. But before going into the mobile remote support architecture, I want to take a step back and talk a little bit about Android. So, Android is a modern operating system, and it means that it has a lot of newer architecture that enables sandboxing features, meaning every app runs inside a sandbox and doesn't have permissions to get to do everything it wants on the device, and the permissions are access-based, meaning an app must require a permission in order to access a resource on the device, such permission to contacts in order to access the contacts, or a permission to access the microphone in order to record. So these permissions are when a user installs an app, he can view those permissions and decide if he wants to install it or install the app, yes or no. And in Android, in the last version that's going to be published soon, Android Marshmallow, Google changed a little bit the way that the permissions work here, but most of the permissions still are the same. So we can see an example for this kind of permissions. This is an app from the Play Store. It's a flashlight app, but we can see that it requires access to a lot of permissions to a lot of sensitive data that a flashlight app usually don't need, such as location, photos, camera, device, and app history. And this is the problem here, because a lot of apps wants a lot of permissions, and the user has to agree or not. are considered, when I say privilege, it means that most apps can't get this kind of permissions. Part of those permissions are permissions such as install packages that allow an app to install other apps, read frame buffer and access surface flinger that allows an app to access the screen and take screenshots or record the screen, and inject events, which allows an app to simulate user control. So how do apps can gain these kind of privilege permissions? These permissions are only gained through system apps. And what's a system app? System app is an app that is pre-installed under the system prev-app folder in the device, or it's an app which is signed with the OEM certificate. So if we'll go over again, go back to viewing the mRST permissions, so we saw that it has a lot of permissions such as access to internet, get app list, access to the device storage, and privilege permissions such as install apps, capture screen, and user input control. So, in order to understand a bit the architecture of the mRST, we'll need to do an overview of the Android customization chain. So when Google publishes the source code, which is called the AOSP, move it to the OEMs, which then does customization to the code and sign it with their own OEM certificate, and then move it to the carriers, which do further customization, and then the device gets to the end user. So what the mRST vendors did is collaborate with the OEMs and got their apps signed with the OEM certificate. And as I said earlier, an app signed by the OEM certificate can gain privilege permissions. Those permissions that we talk about, such as screen sharing and screen recording and user input simulation. So we analyzed a lot of mRST tools, and we saw that most of them had the same architecture. What is this kind of architecture? The vendors split the app into two apps. One of them is a plugin, which is signed by the OEM, such as Samsung, LG, HTC, etc. This plugin, because it is signed by the OEM, it can gain privilege permissions. It's an exported service, and I'll talk later on what does it mean. And it doesn't require any user interaction, and the user doesn't see the plugin in the launcher menu. And also there's another app, the main app. What's the main app? The app is signed by the mRST vendor developer, such as TeamViewer, LogMeIn, etc. It has regular permissions because it's signed by the mRST vendor, and it does all of the business logic of the app, such as handling the network connection and the user interface. So the main app connects to the plugin and uses the plugin in order to execute privileged actions, such as record the screen or simulate user actions. So the question that we ask ourselves is, okay, if the main app talks to the plugin over Binder, which is Android's native inter-process communication mechanism, how does the plugin verify the main app's identity? So, what do we know until now? So the plugin is signed by the OEM. That's the reason it can gain those privilege permissions. It's obtained from the Google Play Store or can be pre-installed on the device, and I will talk a little bit later about this. It's designed to communicate with other apps because it's an exported service, and it needs to talk with the main app in order to provide the main app a way to record a screen and simulate user input. And because the apps talk over Binder, and Binder doesn't offer any native way to verify the connecting's app identity, the validation code for the plugin that the plugin used to verify the main app's identity is reinvented by each vendor. There's no native way to do it, and each vendor had to write its own security code that verifies the identity of the main app. So after understanding all of that information, we decided to go deeper and analyze the various vendors in order to see if they are vulnerable, if their plugins are vulnerable, and if we can attack them in some way. So first, we decided to go over TeamViewer's plugin. TeamViewer, as you might probably know, is a very big player in the PC world and also in the mobile world. It has millions of downloads in the Google Play Store. TeamViewer collaborated with all of these OEMs, which are the big OEMs, LG, HTC, Huawei, Lenovo, and Samsung, all of them, meaning if we'll find something here, we can attack all of these devices, which mean hundreds of millions of Android devices might be vulnerable. And not only TeamViewer has decided to collaborate with all of these vendors, it collaborated with all of these OEMs as well. This is a screenshot from the Play Store, and each square that you see is another is a vendor, meaning TeamViewer has collaborated with a lot of OEMs, and this and vulnerability here might affect every Android device on the planet. So let's do a quick recap for the mRST plugin verification mechanism. So a plugin, as I said earlier, is an exported service. The way Android works is that any app on the device can connect to an exported service over Binder, which is Android's inter-process communication mechanism. And it's the plugin's job to verify the connecting's app identity in order to only work with validated apps and not with every app on the device. So now that we understand this, I'll show you the TeamViewer's code, and I'll give you a second to look if you find something weird here. I'll give you 2 hints about the problematic parts in this code. And now I'll show you what's the problem. So this is TeamViewer's plugin code. And we can see that first it sets an integer, a number as an integer, and a hard-coded serial number. And the second part that we can see is when an app connects to the plugin, what it does, it extracts the connecting's app certificate and takes the serial number from the certificate and compares it to the hard-coded integer that it set earlier. If the serial number equals the hard-coded serial number, it let the app connect and execute privileged commands using the plugin. So the question is, what's a serial number? So if we'll go over the certificate's RFC, we can see that the serial number is an integer, and it's assigned by the certificate authority to each certificate. So then our next question was, who signs applications in Android? Who's the certificate authority of application signing in Android? And where does the developer gets the certificate? So this is a section from Android developers website, and what it says, it's that Android app certificates are not signed by certificate authority. Android apps use self-signed certificates. This means that a developer can generate his own certificate and sign the app with its own generated certificate, meaning that each developer is his own certificate authority, meaning each developer can create a certificate and decide what the serial number of the certificate will be. So this is an example for generating a certificate with a serial number. So I can, as an attacker, I can write an app that can interact with the plugin, sign it with a certificate that has the serial number, the same serial number as required by the plugin, bypass the plugin's verification mechanism, and execute privilege actions on the device using the plugin. So now I'll show you a quick demo . Okay. Okay, so what you are seeing here on the left, you can see this is a movie capturing the demo I did before, and on the left you can see the CNC server, and on the right you can see a mirroring of the connected device. So what is happening here is now that I'm going to install on the device an app that I wrote. The app, as you can see, only requires permissions for accessing the SD card and internet. And the app is signed with my generated certificate with the serial number required by the plugin. And now I'll install the flashlight app. And once I'll hit the light button, you can see that the app will use the plugin in order to record the screen and send the screen to the CNC server. And I hit the light button, and you can see on the left that now I can view everything that's happening on the device. I can, if the user will now write a message, I can see the message that he writes. If he changes the home screen, I can see the home screen. If the user will access an email, I can see it. If the user even uses a secure container that encrypts everything, I can also view it, because even though secure container encrypts the text, if the user can view it, also the attacker can view it. I can also see passwords, I can see everything the user does. And not only I can see what the user does, I can also initiate action on the device. Now I'm opening the call log on the device, as you can see. I can also as well open other stuff, such as opening the search screen and inserting my own text. It will take a few seconds, but you can see that this is text that I insert from the CNC server and goes to the device. So I'll go back to the presentation I have on an Android device. And as I said, I can also bypass the secure containers encryption. So this is the demo for TeamViewer, and now I'm going to talk about another vendor, mRST vendor, called RSupport, which is interesting as well. So our support also collaborated with all of these big OEMs, LG, Oppo, Samsung, Huawei, meaning hundreds of millions of Android devices can be vulnerable as well. What's interesting about our support is in TeamViewer, the user must have the plugin installed or be persuaded by an attacker to install the plugin. But in our support, the plugins come pre-installed on the device, meaning devices are vulnerable out of the box. So we saw that the plugin is installed in a lot of flagship devices, the G4, G3, and the Samsung Galaxy devices. And if we think about it, this means if the app is pre-installed on the device, it's also cannot be uninstalled, which is OEM patch or a new version of the plugin.
Avi, we are losing your voice.
Also, because the plugin is only an exported service without the launcher menu, most of the users won't even know that they have. Oh, okay. So, because the plugin is an exported service without a launcher menu, most users won't even know they have a vulnerable plugin on their device. So, let's go over our support code and see if it's really vulnerable. So, the our supports plugin waits for an app to connect to it, and now when the app connects to it, it extracts a certificate and executes a hashcode function on the certificate. If the certificate hashcode equals a predefined hashcode, it lets the app connect and executes privileged actions. So we ask ourselves, so what is it? Maybe it's an MD5 or SHA-1, SHA-256, or maybe CRC32. So Android, like he asked, Android is open source. So let's go over its implementation and find out. So let's view the hashcode implementation. This is a snippet from Android source. And we can see that the signature, that's the certificates object in Android. The certificates hashcode function executes an arrays hashcode function. And if we'll view the arrays hashcode function, we can see that we have a function that returns an int assigned int. And the assigned int, as you know, is only 32 bits, meaning we have only 4 billion possibilities. And because of other traits of this hashcode function, we can downsize the possibilities into a lot less. So we wrote a script that tries to do brute force and find and generate a certificate which its hash code will match the hash code required by the support plugin. It took us some time, but we succeeded in generating a certificate that does that. So what we did is write an app that can communicate with the bypass the plugin's verification mechanism.
Avi, we lost you for a few minutes. Could you just, for a few seconds, could you just rewind? You created an app from there.
Show here a demo because it's the same as the TeamViewer's one.
Okay, great.
Yeah. Okay. So what we did is write an app. That has and sign it with a certificate and communicated with the AllSupport plugin. I won't show here a demo because the demo is the same as the TeamViewer's one, but just with another plugin. So, what else? We found multiple vulnerable plugins. It's not only TeamViewer and AllSupport, we found other vendors as well. And we didn't check them all. There's a few mRST vendors for Android. And if you want now, you know how to, so you can do it at home. And it's important to understand two things about this. One is that the verification mechanism flaw, the verification flaw is not limited to mRSTs. What we talked about here is those apps that are signed by an OEM certificate, meaning that they allow other apps to connect to him over binder. Meaning there might be other apps that are signed by the OEMs as well, and let other apps connect to it. It doesn't have to be an mRST tool. And another thing that it's important to understand that this vulnerability is not going away soon. Why? We saw that their apps are signed by the OEM certificate. And OEM certificate on Android, it cannot be revoked easily, because if we will revoke this certificate, all of the other apps signed by the OEM won't work. So what does it mean? What does this means is, if I, as an attacker, will get a hold of an old vulnerable version of the plugin, even after a patch is out, I can persuade the user to install the old vulnerable version, and it will still work on the device. So this means that in a year from now, I can still go to a device, install a vulnerable version of a plugin on it, and attack the plugin. So certificate revocation here won't work. So this was very interesting to us, this kind of attack. And it got us thinking, okay, the mRST plugins are very powerful. Maybe we can find another angle, another way to attack them again. So we thought, maybe we can manipulate the main app logic in order to take control of the OEM signed plugin and take control of the device again. So let's view another vendor that we found that we could attack his main app. Allowed changing settings by weird but not vulnerable yet. So we found that one of the commands here can modify the subdomain of the CNC server, meaning it won't be xxx.community.com, but maybe something else. Okay, interesting. We saw that the subdomain can be altered without requiring authentication. Okay, this is a lot more interesting now, because this means that we can change the behavior of the app without being authorized. So this means maybe I can change the subdomain to evil.community.com, which is interesting because it won't let the app work, but it won't let me take control of the device yet. But here came the last piece of the puzzle. The app didn't sanitize the subdomain that got from the text message properly, and allowed us to add a slash in the end of the URL, meaning we can change it to a domain /.community.com, meaning change completely the CNC server that the app communicates with, meaning we can now send a text message which changes the CNC server of the app to a malicious CNC server, and then take full control of the device. Take full control of the device only with one single SMS message. Okay, this is powerful stuff. Now I'll show you a demo again. Okay, so I'll share my screen. Okay, so here what we can see is on the left, we can see the CNC server, and on the right, we can see a mirroring of the phone again. So using the CNC server, we will send a text message to the device. We can see the payload that changes the URL, and we can see on the right that the app, the mRST, started working and connected to our malicious CNC server. Now we sent a command that will open the home screen again, and now what I can do is take full control of the device without the user even noticing. Now I'll open the call log and now press the home button again remotely. View the screen as well. We didn't implement this feature because it's the same as the last demo, but I can view the screen here as well. So what we can see here is the list of apps installed on the device. And I remind you that we got all of this only from sending a text message to a device that had this mRST tool installed. So let's go back to the presentation. Okay. So these are the vulnerabilities that we found. And let's talk a little bit about the disclosure timeline. So in mid-April, we reported all of our findings to the vendors, the mRST vendors, to the OEMs, and to Google. We got responses from most of the vendors, which started working on resolving this issue, the issues that we found. And then about May, June, we started seeing new versions of the plugins that were uploaded to the Play Store. But we have to say that we are still waiting now, even in September, their plugins or main apps. So more conclusions. A lot of issues. Google delegated the responsibilities for verifying, for assigning apps that needs privilege permissions to the OEMs and carriers, and they signed vulnerable code with a certificate, which means that there's no easy way to patch it, because once a vulnerable code is signed with an OEM certificate, we can install it on the device every time. So this means that hundreds of millions of Android devices are vulnerable to this multiple issues that we found, and they will still be vulnerable in the future, even that their vulnerable patched version of the plugins out. So if you're a CISO or even a troubled customer, what can you do? So one, you can check if your device is on the list of the vulnerable OEMs. You can find it in our Checkpoint blog post. And you can try to find out if you have one of the plugins installed on your device and remove it, or on the user's device. And I'll mention that if it's a system app, you can't remove it. You have to wait for an OEM patch update. You can also use another approach, a layered mobile security approach, a tool that can scan your app, you scan the device, your device, scan your apps, any vulnerable plugins or mRST or vulnerable devices in it. You can also use our free checkpoint certificate scanner free app, which doesn't supply constant monitoring but on-demand monitoring. And you can download it to the devices and scan it. You can find the app on the Google Play Store. And that's it. Any questions? Thank you.
Yes, Avi, we have a few questions. I'll go forward with those. So how does the vulnerability affect an organization from a
Okay.
CISO's point of view?
So, well, this means that most of the Android devices on your organization are vulnerable. Even if you have an MDM that might, allow you to lock a device or wipe it remotely, your device is still vulnerable. An app even from the Play Store that can exploit a vulnerable plugin installed on the device and take control of on the device and view the corporate information, the contact list, emails, even secure container encrypted stuff, an attacker can view it, meaning that the devices in your organization are vulnerable now to certifi-gate. And you need to take the appropriate measures in order to protect them. Instead, scan the apps using our scanner, scan the device using our scanner, or use a proper anti-malware, antivirus solution that can that's it.
Okay. We'll just take just one more question from the ones that we have. So there's a question in which they've asked what kinds of attacks can be simulated using this vulnerability, and can there be a loss of PII? Was I audible, Avi?
And yeah.
Okay.
So what kind of apps can use this? What?
Now, what
Okay.
kinds of
Yeah.
attacks
So
can be simulated?
every app can. Can you come again? I didn't hear you.
Sure. What kinds of attacks can be simulated using this vulnerability? And if so, can there be a loss of PII?
So, as I said, the plugins are probably has the wildcard permissions, meaning everything can be done on the device using the plugin. So this means that PII data can be stolen using this vulnerability. We recently found an app on the Google Play Store that used this vulnerability in order to record the screen, meaning your organization and you don't want the users to record the secure container screen, but they can do it using this app. So this means that this vulnerability is happening. It's in the wild and can be used to attack your device, and that's why it's very interesting to us as a security research, and it's a very important to our community to understand how it works and how to mitigate it.
Okay, are there any best practices or advice for a CISO to protect his organization against this? Was I audible, Avi?
Or a certificate scanner app, or you can ask the users to use our free certificate scanner app in order to see if their device is vulnerable. Or you can use an enterprise solution that can scan your device and monitor it constantly in order to understand and in order to see if it's vulnerable. And then it's also very important to update your devices to the latest Android version that you can have, and upgrade all of your plugins and to mRST tools on the devices.
Okay, great. Thank you, Avi. We were very lucky to have you for today's webinar. I hope this was a very enlightening session. Thank you everybody for joining us. You will find a survey once you end the webinar, which is on CPI. So it's a rating that we have, CISO Platform Index for security products. So kindly fill in the rating against each of the security products that you would have used and you would like to rate. Based on that, we have a user rated review. You can see the average. There's a method that we use. So you get to know the user feedback for the security products. Thank you so much. I look forward to meet you at the next webinar. Thank you, Avi.
Thank you.